All right, so let's look at the application here. A 100 Newton force and a 50 Newton force. So 100 Newton force, and it does say that they are perpendicular. So I am going to assume for the moment that these forces are going to be on the origin here. That's not a bad assumption because we have no other data. All right, act on the same object. So the angle between the two forces is 90 degrees, so that's why I placed them on the axes. Find the magnitude and direction of the resultant force. So if we were to break this down into components, this one here, this vector here, would be 0 and 100. And this vector here would be 50, 0. Now, notice my assumption might be different than yours. You might have put the 50 going up and down, or going up, and the 100 going this way. So there is no restriction on it. So that means my result is not the 100%. Now, what will be the same for everybody will be the magnitude. No matter what, it will always be the same. Okay, so I want a resulting vector that's going to be something like this here. And when we write that out, actually, it's not too crazy. It's at the altitude of 100 in my case. It's at a horizontal of 50. So there's my resulting vector. So that's its direction. Now its magnitude is going to be, if I call this one V, then the magnitude of V is going to be 100 squared plus 50 squared, and we square root that. So we end up with the square root of 12,500 and square root that. All right, 111.8-ish is my magnitude. Now your directions here might be different, this vector. It's not asking us to find the angle that it's formed. It just says direction. So the magnitude itself in component form gives me direction. This is direction. Remember slope, I can say this can be rewritten as slope pretty darn quick. An airplane flies east 210 kilometers before turning south 20 degrees east and flying 100 kilometers. Find the distance and bearing of the plane from its starting point. So it's flying east 210. Yeah, in some worlds east is the other way, but come on. All right, now it's going to turn. Now it's going to be based on the south. So here's the south bearing. And off the south, it's going to be 20 degrees. So it turns quite a bit because this angle deep inside here has to be 20 degrees, right here, like that. And that flies 100 clicks. So now what we need to do is find the resulting vector right here, because we just want to find out where it is relative to the original, as if, what would I have flown if I never made a turn? Now, of course, they could be going around a storm, so we've got lots of reasons for the turns. Or maybe they had to go around a building or something like that.
So wait, do we have to use the vector on these ones? Because I used the law of cosine.
Okay, so the law of cosine, good, using this angle here as 110 degrees. And if we call this vector v, then to find the magnitude of that, we can use the law of cosine. Good, so now we can use the law of cosine here, using one of my sides as the magnitude of v. So remember, this squared is going to be equals 210 squared plus 100 squared minus 2 times 210 times 100 and times the cosine of 110. That's cleaned up a little bit there.
I think Jillian.
All right, so approximately 261.66. So that would be a kilometer measurement. In order to find the bearing here, we have to find this angle theta, but it's off the south right here. So it's off the south and it's going in the easterly direction. Right, so we're going to, we have to find that theta in order to find a different, this one right here too. Because that's what my answer is going to be. So finding theta in the triangle is, then I can complement it that, and then this is going to be my answer. South, this angle, and east. So we can use law of sine. Law of sine. Law of sine, because we have 210 here, or excuse me, 110. So I can put sine of 110 down below, and its magnitude above, approximately 261.66. And that's going to equal the 100 over the sine of theta. To get approximately, theta is approximately 68.95 degrees. And when we supplement that, complement that. So our final answer now, since we complement that, is going to be south, 21 degrees east. That's my bearing. Good, so I did catch the error here. I accidentally pressed cosine on my calculator. So that means this answer is actually the 21 degrees, which means my answer here is the complement, which was the 69 degrees east.